Data is growing faster than businesses can control it, and the wrong storage decisions today will cost you tomorrow. From AI workloads and rising costs to supply chain pressures, organizations are being forced to rethink how they build and scale their infrastructure. So how do you choose storage that actually lasts, performs, and protects your business long term? Let's dive into the conversation.
Hi, I'm Quattromini from Fortuna Data. Welcome to Smarter Strategic Thinking. Today we have Matteo from Kingston Technology. Matteo.
Hello.
Nice to see you.
Nice to see you. Thanks for having me.
First of all, do you want to tell our viewers a little bit about Kingston and who you are, where you're primarily based and founders, etc.?
Kingston Technology in general was founded in 1987. We're still privately owned by two gentlemen, David Sun and John Tu. We've started back in the days with just one product that was a single inline memory module that was a revolutionary memory solution due to shortage. And since then, we've developed into different product categories much more. So we started with just that one, but the plan was to expand across the board in the technology. In fact, for the past 3 decades, almost 4 decades, we've become a trusted brand, storage and memory. Not just storage and memory. Fun fact, people mostly know us for our USB drives, which are really fancy, they're very popular. But not just USBs. In fact, Kingston is much more than that because we cover the full spectrum. From the home overclocker to the Internet of Things, to the data centers. We have SSDs, all sorts of SSDs, memory flash cards, USBs, standard, as well as encrypted, and of course, our memory solutions. We're committed to reliability, to very high quality products, to expertise that is open to everyone.
How long have you worked for Kingston? What did you do before, and what is your role today?
So I've done all sorts of things. My background is very diverse. I've been in Kingston for a bit more than 3 years now. So I've started as a technical support specialist, where I was taking care of post-sales, dealing with issues, trying to solve problems, troubleshooting, that sort of space. Whereas right now, I've developed in these 3 years, and I've become a field application engineer, which might mean something or might mean nothing. Yeah. It depends how you see it. But basically, what I do is I am the bridge between our customers and our engineering department. Customers can reach out to us, to me and my team, literally directly. And what we want to do, we want to find the best solution and solve deployment and compatibility problems before they become production issues. We validate, we optimize, we support the deployment of memory and storage solutions.
From your perspective, we all know that there's a severe storage shortage. How do you think that businesses themselves should handle this shortage that's 2, 3, 4 years, depending on who you read, and the prices are obviously going up and up and up as well, aren't they? So what is your take on this, and how does Kingston as an organisation try to circumvent some of those shortages?
We manage supply as a result of our long-term relationships. We have worked with key manufacturers for decades, and these relationships did not just happen. They've always been strategic. We have a disciplined multi-source strategy, so we don't just source the components from one manufacturer. We use several of those, so we always have a choice where we want to buy our components and then assemble them together. Because we're still privately owned, we prioritize our long-term relationships, so we don't just look at the short-term win. We want our standing relationships and partners to know continue. That, yes, exactly. It's more of a continuous approach with the supply. We're also proudly channeled first, so we always prioritize the channel. I know that Tom from QNAP was here.
Yes, he was.
It's one of our latest and most successful relationships with our partner. For example, with QNAP, we've worked together with their engineering department to cross-validate products. Right. So in their QNAP systems, our DC600 series and our DC3000ME series enterprise-grade drives are now certified and validated to work in their QNAP systems. So that's an example of the outcome that our close relationship with a partner can have.
Yeah, that's how we met you guys. We've got a QNAP over there that's for customer evaluations, and we met Kelly and her team at the QNAP event in London. So we heavily rely on QNAP. We work with QNAP. We're a QNAP distributor. So that's really good. This is off tangent, but last week I went to Space Expo at Excel. And do you do any sort of military grade space type memory?
We support those with mostly with our encrypted solutions. So that will be the Kingston Iron Key product line. These are hardware encrypted USB drives. We have customers that use them in military environments because they physically cannot be tampered, and they have some certifications that protect them from physical tampering to physically access the chips. So you cannot physically open a drive and access the chips and remove them and put them in some other.
Nothing like Mission Impossible then.
Nothing on Mission Impossible, no. Unfortunately, no. With those Iron Key drives, your data cannot be accessed unless you have the password. You cannot physically get to the chips. Because these military-grade drives are filled with epoxy, which solders all the components together. And if you were to open that drive, you couldn't really physically access to the single chips because everything is soldered together. So the moment you try and break and open the drive, it'll break, and the drive will detect as well some physical tampering. So it'll kill itself before you can actually get to the chip.
From our point of view, there's a lot of different types of chips. You've got SLC, MLC, TLC, QLC, and then you've got DWPDs, which are drive writes per day. If you could explain to the audience what that means, because I know some of our partners and vendors have bought storage in the past and said, well, after 6 months it stopped working. And then you say, well, what's your application? And then they say, oh, well, we're doing this or we're doing that. And then they start scratching their head because they're not aware of these issues. So do you want to just explain what that is?
Sure. So you have different types of NAND and different grades of NAND within the same categories as well. So you have SLC, which can accommodate only 1 bit per cell. That means one piece of data, either a 0 or a 1. We're talking binary code here. So either a 0 or a 1 in one single cell. Then you have multi-level cells, types of NAND, which can accommodate 2. Triple level cell can accommodate 3, and quadri-level cell can accommodate 4. So basically it's all linked to the endurance of these cells. You need to think of it like, imagine a massive building with a lot of cells that are identical, and then you want to put some people in there. These are these are your bits of data. You put one person in a cell. This person will not argue with anyone. Perfect, nice and chill. They're fantastic and can stay there for long. You start to put 2 people in that cell. They may have some arguments at some point, there may be some problems, but 3 people, even worse, 4 people, even worse. And the things that you use in this cell will wear out quicker because you have more people using those facilities, for example. So since this is related to the endurance, basically a single level cell will last longer and have more endurance than a quadri-level cell, generally. But then, as I said before, you have different types of NAND. You have enterprise-grade NAND, and you have consumer-grade NAND. So this does not always mean that a quadri-level cell will last shorter than a single-level cell. There's always a balance how you use the NAND. You can also program, for example, a triple-level cell to work as a single-level cell. So that will be a CSLC, pseudo single-level cell. So there's all these sorts of decisions that need to be made beforehand when choosing what NAND you put in a storage device.
What companies need to work out is what their workload is. If it's video and post-production, they're doing a lot of editing, then I'm assuming you need like an SLC or a TLC, and then work out how many drives you're going to be doing and drive writing and everything else. So, and that's often overlooked.
It's often overlooked. That's true, and that's where we come. That's where my role, for example, is there for. So I'm there to help customers make the right decision. Now, it's not just about SLC, TLC, MLC, QLC. It's not just that, because based on the different type of NAND, you can have a TLC that has great endurance. This happens. Our enterprise drives, for example, they're not all SLC, because you wouldn't need that. That's also much more expensive. So it's always about finding the right balance. For enterprise-grade drives, the Kingston ones, we always advertise the drive write per day value. It tells you how long the drive will last over its and how much you can write into the drive over its life cycle. So this can really help you make the right decision. If you need to replace a number of drives, you want to pick the one with the drive write per day value that suits your workload.
For example, if you've got a 2.5-inch SSD with SLC chips in it, that is going to be a smaller capacity than maybe a similar drive with QLC, but it's you've got to weigh up whether you want drive writes per day or you want capacity. That's what it boils down to, is longevity or or capacity.
It's always about that, the price, longevity, capacity, because of course SLCs, they will use more physical space on the PCB because you need more chips, because in those famous cells in the building that we mentioned before, if you can put only one person in each cell, then you have less bits. If you can put 4 people in the same cell, then you have more capacity but lower cost.
What makes your storage memory different from other vendors? What do you do any extra check-in, or you've got certain vendors that you always go to? What makes Kingston different?
What makes Kingston different is generally the reliability of our products. And this comes from BOM, bill of material control, for example. We've mentioned that we can buy from different manufacturers in terms of NAND and controllers and memory. Yeah. We apply a strict BOM control. For enterprise-grade products, we only select certain components, and we try to maintain the BOM as stable as possible. So we don't want to make many changes there, because we know that stability is critical for enterprises. Every time you make a component change, organizations might need to revalidate and retest that build. So we want to reduce the downtime for them to retest the drives. From this also comes firmware stability, because so the firmware is as stable as possible, because we try to change the components as less as possible. All our products are 100% factory tested. So every single product that leaves our factories was tested beforehand. Now, depending on the application of this product, we do different tests. For enterprise grade, for example, we do stress tests for memory, burn-in tests that simulate the workload of several months on a single memory module to expose some bad cells, may there be any. And if one single cell is defective, then the product does not leave the factory. So this gives us the trust to offer a lifetime warranty on our memory products, which is also something we're really proud of.
Yeah, it's quite unusual.
It's a lifetime. And on the SSD, enterprise grade SSDs, we offer a 5-year warranty. With NAND, this will wear out at some point, and this is normal. It's not just Kingston's. Again, we're channel first. For the configuration that you need, you can use tools, for example, the Kingston Product Finder, what we call the configurator, which is on our website. You simply look up your system and you will find a list of products that are tested, verified to be compatible with your system, be it an OEM, be it a general motherboard, a server, desktop, anything. You'll have the products that are verified to be compatible there. We're happy to share BOM details. If you need consistency over the components, we offer solutions like full lock for memory or DRAM lock.
Right.
For full lock, we lock all the components of the memory module, so that you're sure that whatever you buy now is going to be the same the next time you buy it, because the part number tells you exactly the components that are built on that memory module. And this is important for enterprise customers when they want consistency, because if you change the components, there might be some
fluctuations.
Exactly.
Yeah.
We're also happy to share transparent roadmaps. So whenever there's big purchases over years or months, we're happy to be transparent and tell you, okay, this is going to be available in some months, or you may want to pick this other one because it's going to be more available. It's always changing that.
And what is your largest product at the moment in terms of capacity, and what interfaces can you support from a enterprise customer?
For SSDs?
Yeah.
So the largest one at the moment is 15 terabyte with DC3000ME. For enterprise grade SSDs, we cover SATA and NVMe, PCIe Gen 5.
Yep.
So with SATA, we have DC600 and DC600ME, which is the 2.5-inch SATA solution up to 7.6 terabytes. We have the standard version, the 600M, and the encrypted, self-encrypted version, which is the C600ME. So that supports self-encryption with AES to 256 for those who need it, with TCG Opal or similar encryption solutions. And then on the NVMe side, the DC3000ME, that's used for AI workloads, because they are purpose-built for these type of workloads where you need that kind of speed, and you need to move massive data sets into the memory, and you need to do it fast and efficiently, because memory will always be faster than storage, of course. And you want the storage to be as close as possible in terms of speed. So if you use NVMe Gen 5, then you can really move those data sets really fast.
And you said you support PCIe Gen 5. What are the speeds of that?
That's a theoretical maximum of 14,000 megabytes per second. That is really
That is
fast.
shifting.
And we can achieve those speeds. But the benchmark charts are quite clear. We can achieve those speeds with this drive, with the DC3000ME, and also prosumer grade SSD. We can get to those speeds with our Fury Renegade G5 SSD. That's also a PCIe Gen 5.
Are you as an organisation seeing a big uptake in AI, or is it vaporware? And what are your thoughts on the whole AI market?
Well, this is a big question. But yeah, no.
There's lots of cash being put out there.
We're seeing a lot of demand in terms of being ready for it. Because, everything, there's a switch towards AI workloads. Organizations want to have their own AI workflows, and they want to run them locally, for cyber resilience and for data security. So you want your AI engines to run locally, and you need the hardware to do that. In
your opinion, are organizations bringing back some of their workloads because of, if we're talking about AI, it's bandwidth intensive, and whilst you can have a little piece of wire like that going to the internet, it's not exactly like this, is it, when you can get on premise? So are they bringing them back specifically for those workload cases? We are seeing organizations bring back data closer to where it's generated, especially in the European Union, a bit for data sovereignty and data security. But yes, generally organizations now, I see that they are condensing more workloads into more powerful servers, but they want to have them running locally instead of relying on external data centers that do the work for them. People like to have their own machines. So they're sort of building a fortress around their environment. Yeah, it's related to risk assessment and to data security. Yes. Regarding memory, I don't know how many memory manufacturers are there, but obviously you work through the channel. So if we've got viewers looking at this, how would you? It's not all about price at the end of the day. No, not at all. Sometimes in a business they think, well, memory's going up in price as storage is going up in general. Being with Kingston as a provider, what you're telling me is you've got that historical relationship, you've got certificates of conformance in terms of you can track back in terms of you built that component using that system, and that to me is quite a valuable thing from an organisation, especially when they're building these systems, trying to build these systems if they could get their parts together, and they need that ruggedness, reliability and performance. Is that what Kingston's bringing here? Definitely, yes. So as you said at the beginning, it's not all about the price, not at all. In fact, we're there to help the decisions makers ask the right questions prior to an upgrade or a replacement, because usually conversations start with so what's the price or what's the cost per gigabyte? Yeah, it's not just about the cost per gigabyte. That is a fair question, don't get me wrong, but if I were to advise a CFO, I would suggest to look at the total cost of ownership of an SSD, because that covers all the costs related to the single drive over its life cycle. So it's not just the acquisition of the SSD, it's maintenance and eventually maybe its replacement as well over the life cycle. So you look at the endurance of the drive using these values like the drive writes per day, the terabytes written, the mean time between failures, so you know what to expect. You pick the right drive, which may be more expensive, of course, but there is a reason behind it. In general, in technology, you get what you pay for. So if you pay a bit more for something, there is a reason behind it generally. Yes. So if you need to upgrade your organization's storage drives and you only focus on the cost, you may get a short-term win there, but eventually you may be forced in the future to forced and rushed upgrades because those drives are not built for that type of workload. You saying that, this brings me back to my question 12, and this is quite pertinent in terms of, I'll just read this out. What decisions today will business regret in 5 years? And this is what you've said. If you buy something that's, maybe 20 or 30% cheaper than the competition, and it fails in 2 years, and guess what? You can't even buy a replacement. Then, have you actually saved any money? And for me, I think it's all about, and I've got Kingston drives in my systems, and and they do run quite reliably, and I don't think I've ever had a failure, to be honest. But that's not bigging you up, but it's a fact.
It is a fact. It is a fact. They're reliable. And yes, probably because you've also made the right decision when you picked your drive. Decisions today that businesses will regret at some point are those driven by short-term thinking and short-term cost thinking in general. Yes, you pick the right drive with the right endurance. You look at your workload. You see, you talk to an expert, for example, who can help you pick the right product. It'll be possibly more expensive, yes, but then what you want to avoid is downtime, because downtime is costly and it's reputationally risky as well. You want your organization or whatever you're doing to continue working. You don't want any interruptions there. You don't want to be forced to replace your drives because they've worn out much before than what you're thinking.
You have NVMe, you have obviously memory at the top, which is the fastest. Then you have NVMe, then you have SSDs, and currently you have HDDs, and then you have potentially tape or the cloud at the lower level in terms of performance, the performance layers that you get. So from your point of view, where do you see Kingston sitting? Is it NVMe, SSD? Is that where your primary, or are you moving more towards NVMe?
There's a shift towards NVMe with organizations, but that doesn't mean that we're not supporting SATA anymore, because we're still covering those, and SATA basically is basically selling itself still, because for what we're seeing is a shift towards NVMe-based drives for hot data. So for data that's being constantly used, and especially for workloads like AI, where you need to move those massive data sets fast into the memory. But for those data that you do not need every day and that can run a bit slower, you can rely on SATA more for, I don't want to say archiving because that will be the next level, but for data that can be there because you don't need it actively very, 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 very often. So for whatever needs to run fast every day, you can rely on NVMe because you need that kind of speed, and then SATA for the rest.
One of the questions that you and I spoke about before the video started was where SSDs and NVMe sit from an archiving perspective, and what people don't understand is that you do have to periodically power these, maybe once every year or once every 2 years, or you just can't take an SSD and stick it on a shelf because it's like a battery. Over time it loses charge, doesn't it? So
I like this comparison with the battery. Yeah, it's true. I mean, the flash technology in general, not just Kingston, but flash technology relies on electrical power to retain your data, and depending on the type of NAND, depending on how new the drive is, or how worn out the drive is, whenever you write data into it, there will be electrical circuits to retain that data. And then it's good to refresh those data from time to time to make sure that they remain there and the electrical power does not just wear away.
So they're not an archive medium. They could be, but you've got to do that power cycle, otherwise they will degrade.
They can potentially, I mean, flash technology wears out, that's normal. It's not infallible, and it wears out. Depending on the type of NAND, depending on the product, depending on how you use it, depending on the temperature, on the humidity, on how much data you've written into it, how often you read off it. There are things that you can do to keep your flash fresh.
Yes.
We've seen USBs last for 10 years. We've seen SSDs retain that data for a lot of years without being used. So there's a lot of factors that play a role in there. It's not just about how often you refresh your data. But yes, refreshing can definitely help maintain the cells.
So there you go. You've learned about archiving there. What's the next technological breakthrough from Kingston's point of view?
Oh, this is an interesting question because everybody expects like the brightest of the newest of the fastest component. I don't see as a next technological breakthrough a new shiny component. I see more an architectural change in the way organizations choose and manage their devices. So it's a full architectural change with more intelligence, how you want to manage your storage and memory, the decisions that you make. There is certainly a shift towards PCIe Gen 5 into mainstream, but again, only for hot data. But fun fact, there are organizations that are not even fully utilizing Gen 4 yet. So when you make that decision and you want to go towards newer technologies beforehand, you want to make sure that your architecture can actually support that.
Yeah.
Because otherwise you're over investing in something that you cannot use. It's like having a sports car that can only run on second gear. You don't want that. So you need to make sure that everything works. And then I see CXL, Computer Express Link, which allows for memory pooling and dynamic allocation of memory. I see this coming from time to time. I don't want to say that this is going to be the next technological breakthrough, but there is, I think, something there with allocating the memory dynamically when you need it, instead of having memory allocated in one server, immutable, that you cannot allocate whenever you need it. So this is good.
Do you see a market for, as an interface, a silicon photonics interface? And I don't know where we are on the roadmap. Let's say you had a pool full of Kingston memory in a shoebox, and it had a silicon photonics connector. And so in a data center today, a data center could be like the size of a football pitch. All those components in that data center are all cooled pretty much to the same temperature, regardless if it's a CPU or if it's a tape drive. They're all in the data center. They're all cooled at the same temperature. So what silicon photonics is it's a terabit connection using optical. And basically what they're saying is that you could buy a shoebox of Kingston memory, and that could go in a broom cupboard. And the broom cupboard's got, and all they do is add another box, another shoebox, and they connect it up, and they connect it up. So what you would have is you would effectively have throughout a building a vertical data center rather than a horizontal data center, which obviously, as you know now, you can get a petabyte of storage in that much space. You know, it's crazy. So people don't need as much space as what they perceive to be. And what they're saying is that these connections, these terabit connections, are like micro latency performance. The operating systems, and Microsoft actually have this supported already, and a few Linux operating systems. Whereas if I came along with my shoebox full of Kingston memory, I plug it in, I've got terabit connections, and literally the operating system knows straight away that I've plugged in another petabyte of storage. Bang, and it's already there, and it knows what to do with it.
I suppose that is part of the architectural change with more intelligence that I was mentioning at the beginning. So we need to rethink the way we want to allocate memory, we want to use storage. It's going to change, because now we're with motherboards and CPU, memory and storage, but possibly there's going to be a big shift on how this is going.
The idea was, and to me it makes perfect sense. So you buy a box of CPUs, shoebox of CPUs, you buy a shoebox full of memory, a shoebox full of Kingston SSDs, and they all connect together in one seamless thing. So rather than building a flat server, a flat system there, everything's stacked. So you stack it up and you buy what you need. And that's what they're working on. Dell's working on this as well, actually.
So you wouldn't rely on a PCB that electrically and mechanically binds all together, but you would rely on fiber. Yeah. And you basically play with your components depending on what you need.
So you know, from a virtualization point of view, you might need some extra CPUs. So you buy just a box of CPUs, you plug it in, and the OS automatically knows, and it uses those CPUs. And to me, it makes really smart sense, and you get very dense. It's very dense, but it's super cool. You know, that cabinet there is CPU, so that needs to be cooled the most, and then, you know, so your cooling costs come down massively as well.
Yes, I see something in common with CXL. Because, you know, you're dynamically allocating whatever you need, and you can move.
Yeah, and it does it so fast in the blink of an eye. You know, the performance is phenomenal because it's all traveling at the speed of light. And I saw this originally, probably 7 years ago. So 7 years they were talking about this, and I spoke to someone a couple of years ago, and it's still being developed. So it's called silicon photonics, you know, and it's a really, literally, you get the cable like USB, plug it in, bang, we've got some extra memory, or we've got some GPUs in a box, or whatever it is. So everything's shrunk down. Rather than building a whole circuit board of components, you buy what effectively you need.
That'd be fantastic to see. And
it would, wouldn't it? You know, you can really, when you start thinking about it,
it's mind blowing.
Yeah.
But I really want to see that in action at this point, because we're so technology. You think that technology is very fast in developing, and there's the latest of the newest and the greatest every single day. But then to see something actually being implemented, that is a much slower process. So we always don't want to overhype big technological breakthroughs. It is, as I've mentioned before, people are not utilizing Gen 4 yet in their server infrastructure. So this is going to take a lot of time. You might have that greatest new breakthrough there, but then when are you actually going to see it in action?
Exactly. So that's just one for you to watch, but it's coming. Apparently it's coming. But I think part of the problem is to do with certifications and getting everyone on board, to buy into this. I think Lenovo were doing it as well, I think they said, didn't they, when we met them? So they're all these manufacturers are developing this in the background, but it might not come out for 10 years.
Probably. Exactly, yeah. We're seeing now even new memory form factor, and this is taking long for implementation.
Well, you talk about the U.2.
The U.2 for SSDs.
U.2's been around 6 years.
Yeah.
And it's only now starting to become a little bit more mainstream, isn't it?
More mainstream, exactly. Also for memory, there's new form factors coming. There's the CAM2. Basically you need to rethink the way a memory module is plugged into a motherboard. So instead of going there vertically in the socket, it's applied horizontally, like on the PCB.
Oh, okay.
And it connects with I can't remember.
Like an EEPROM?
Like an EEPROM, yes. Yeah. It connects over the motherboard horizontally.
Yes.
To save some power,
Could they be stacked?
Thermal management, and it's screwed onto the motherboard. So you save space. This is for rugged devices, mostly like laptops are very compact systems. But yeah.
Why is storage suddenly back in the boardroom on the agenda of 2026?
Storage used to be an IT line item in the past, but now it's not that anymore. Now it's directly linked to competitiveness and risk, because first you have AI model training that you might want to do in your organization, and that is massively data hungry. So you need to make the right decision how many drives you want to have, the capacity for each drive, the capacity that you actually need. You need to be ready for these data sets to grow, because this is a constantly growing type of work. You pick, for example, 100 SSDs, 50 gigabyte each, or you pick 50 drives, 100 gigabyte each. There's a difference there, because the 100 drives will all use their own power even when in idle. So if you don't use some of those drives, they will still be using power. Whereas if you pick 50 drives with higher capacities, you can there's differences there in terms of power consumption. Explosive data growth in organizations that are producing more and more data more than ever, and they want to keep them closer to them for sovereignty matters. These data need to be cyber resilient. The boards now want to know, if we're hit tomorrow by a cyber attack, are we protected? How are we going to manage this? Are we going to have some backups? Are our drives self-encrypting, for example? How are we gonna get through this? They want to know this, and so you need to implement drives that can be protected and strategies that can protect your data, like offline backups, for example. Air-gapped backups that cannot be accessed online, so you know that your data is there and nobody can access those through the network. These kinds of strategies. And then again, there's energy efficiency as well.
Yes.
So back to what I've mentioned before about the number of drives that you pick. Each drive has their own fixed idle power consumption. So you need to think of that.
Yeah.
When you want to populate your slots, not just populate all the slots because they look better. You need to populate the right slots with the right capacities. And same goes with memory.
Yeah. Matteo, thank you very much for coming in.
Well,
Appreciate it. You take care. Thank you again.
Thank you.
Thank you everybody for watching. Take care.
Thanks.